When you plot a lot of coordinate pairs on a grid, it's called a scatter plot, just because the dots are kind of scattered all over the coordinate plane. So a scatter plot is just defined as a graph in which the values of two variables, I forgot an S, are plotted along the two axes to determine if any correlation is present. And so we're going to need to explore what they mean by a correlation being present. So let's look at this first example. You've plotted a bunch of coordinates, x and y, and you came up with something like that, a picture that looks like that. Well, because that graph seems to be rising, like it seems like you want to throw a line through there, doesn't it? It seems to be rising from left to right. And so when that happens, we say that we have a positive correlation between the data, or between the x values and the y values, meaning as your x values are increasing, your y values are increasing, and that is called a positive correlation. It's the same idea with this next graph. You almost want to throw a line through here. And what's happening here is as your x values keep getting bigger and bigger, your y values are actually decreasing in this situation. And so we call that a negative correlation. And that means as your x values are increasing, your y values are getting smaller or decreasing. And then finally you have this third possibility when you graph data, and that is you're completely scattered and there doesn't seem to be any relationship between your x value and y value. And so if that happens to you, it just means that there's no relationship or no correlation between that data. It is purely just by chance that those things got thrown together in order to graph them. So these are the only three kinds of correlations that you'll have. So let's practice that concept. Here we're supposed to determine what type of correlation, if there is any, that the scatter plots below have. And I think it's kind of fun to look at the labels on the axes and decide what we're actually comparing. So looking at letter A, it seems we're looking at your GPA and the hours per week that a kid would watch TV. And so this is the scatter plot, and the dots do seem to have some sort of relationship. It's not a very tight one, but we could throw a trend line through there if we had to, because as your GPA is getting higher, it seems like your hours per TV watching are getting lower. And so that is a negative correlation. As your GPA gets higher, your hours per TV per week are getting lower. Or you could reverse it and say the more TV you watch, the worse your GPA is. I bet that's true too. Letter B is your exam results versus your hours of reviewing or revising. And you can see that the hours spent, as you increase those hours spent reviewing the material, the general exam results were going up. And so that is a positive correlation. Letter C is your height and your self-esteem. And this is actually interesting. I heard this was kind of true. The taller you are, the more confident you might be. Not always true. I know some very confident short people, but there seems to be a general relationship there, and it's a positive one, that the taller you are, the more self-esteem you might have, just because you're towering over people and making them feel bad for being small. Letter D is your income versus your years of education. And your income seems, as it increases, seems to be dependent on your years of education. So because your level of education increases your income, there you have another positive relationship. Letter E, people with the flu versus people getting the shot. So the more people that get the shot, as you're looking over in this direction, the less people are getting the flu. And so that trend line is a negative one, which in this case is a good thing. Negative trend does not necessarily mean that bad things are happening. And then finally you have F, the number of miles walked per week, and the amount of gray matter, which means your intelligence. And I'm sorry to say, you cannot increase your intelligence by walking more, according to this graph. And so there is no correlation there between those two data sets. So now we're going to move on and actually make our own scatter plots given data. And we're going to find out if there is a correlation between the number of hours you work and the amount of money you earn. You might make an educated guess right now, but you should let the data decide. So remember, with any scatter plot, it's important to realize that you have two axes. You have your x-axis, which, if you know from science class, is usually your independent variable. In this case, it's going to be your hours worked, because that's pretty static. You either work 0 or up to 15 hours according to this. So this is going to be our number of hours worked. So you need to label it. And then that leaves our y-axis is going to be your amount earned. So I'm just going to put a money sign there. Just put something down. And then usually you should have a title. So this, you can cheat and just use the labels. And so this will be hours worked versus money made. Okay? And now your next step is to come up with a scale for your x-axis, the blue one. And so you can see your lowest value is 6 and your highest value is 15, and I'm guessing all those numbers going by ones would fit. And so we don't skip any spaces. We start with 1, 2, 3, 4, and because I'm getting tight, you can skip writing the number. So I ignored 5, moved on to 6. Either way you want to do it, it's fine. It's kind of a matter of how much room you have. But you need to make sure that your intervals are the same. And we're going by ones here. I'm just not writing them all. Okay. And then looking at your y coordinates, the least amount of money made was $25. And the largest amount of money made was $63.75. And so I don't want to go by ones here. And I almost want to start at like 25, and maybe, I'm just looking at it, and this is what you do too, walk through the same process. Maybe go by 5s. And so a little technique people use, you don't always have to use it, but if it works, do it, is to what's called break your graph. And that means we're skipping a bunch of numbers because we don't want our data to be all smashed up here, so it's spreading out the data for us. And I'm going to start at 25, and I think I said I was going by 5s. So we'll have 25, 30, 35, 40, 45, 50, 55, 60, and 65. And I almost could have even gone by maybe 2s or 3s, but it works. I'll never mark you wrong really on your intervals, but there are better ones to use depending on the graphs that you're given. So now I would like you to go through and plot all these coordinate pairs and see what kind of scatter plot comes out. We can do it together though. I have 6 and 25.5. I'll do some of them with you. So we move over to 6 and then we go up to 25.5, and there's going to be a lot of estimating here, and that's okay. And then we have 12 and 51, which is just going to be a little bit above that line. And 11 and $46.75, which is basically 47. So 11 and then 47. And 9 and about 38. And I did that in the wrong spot. And then 15 and 64-ish. Up here, I did that in the wrong spot too. It's not easy on this machine. 15, 64, and you can already see that there's a trend happening there. And then 10 and 42-ish is here. So by looking at the data, that's a pretty strong correlation. The tighter it looks to a line, the stronger the correlation is. And so this is clearly a positive correlation. The more money you make, the more hours you work, the more money you make. All right, I want you guys to try this one on your own. We're going to say that your hours watched is your x-axis, so we're all doing it the same, and your test scores are the y-axis. So make a label, pick an interval that fits all your data on there, mostly. You can have 1 or 2 go off sometimes. And then plot your scatter plot and come up with a correlation, if there is one. Pause the video. Alright, and here is the scatter plot I ended up with. Now yours will look different if you pick different intervals, and that's totally fine, as long as your intervals were constant. So I'll just explain mine quickly. On my x-axis, I went by 0.5s, or I skipped a line and wrote the integer, and then I broke my y-axis. You didn't have to. If you didn't, that's fine. And then I went by 5s, but I only wrote by 10. So 50, 55, 60 is the way I did it. No matter how you did it, as long as you follow the rules, you'll be okay. But the important thing is to notice the correlation. And here the correlation is as the number of hours increases of TV, your test scores decline. And so that is a negative correlation. All right, thanks for watching.